Hi everyone. I was going to say welcome to today's working group, but this is not the right time and audience. So welcome to our talk. So Tekton passed to us SLSA Level 4. Essentially how Tekton can help secure your supply chain. I'm Vincent Demeester from Red Hat.
I'm Vibhav.
I need to speak closer. Okay. Okay. Right, so I'm Vincent Demeester from Red Hat.
I'm Vibhav. Nice to meet you guys.
All right. So what we're going to talk about today, first we're going to talk a little bit about what SLSA is. If you don't know, I guess everyone knows, but we'll go through it anyway. Then we'll talk a little bit about what Tekton is. Then we'll do a demo. Hopefully this is the core of the talk, and we will recap afterwards. So what SLSA is? SLSA is a framework, a security framework for helping securing supply chain. It's more of a checklist or a best practice, but like it's there to helps you secure your supply chain. I don't have my notes. And essentially, it's meant. It's not meant. It's it's organized in 4 levels. Well, it's in the spec. In the current spec, it's 3 levels, and there was a 4th in 0.1, and we kept it. So that's why we said level 4. Even though if you read the spec today, it's 4. It's 3 level. Why doesn't? Okay, back. All right, so we'll also define a bit of words to make sure we all talk about the same thing. So in the rest of the talk, we'll talk about artifacts, which are anything, any software, any packages, anything that was generated, built by your system. Then signature, which is cryptographically proof that an artifact has been signed and by whom it has been signed. Then the attestation, which is, some metadata attached to an artifact, how it was built, by whom, etc. And it should be signed as well. Provenance, which is what I just said. Attestation is just a generic way of this. And SBOM, which is not how your software or your artifact was built, but more what was built. So from which source, which dependencies, etc. All right, so what are the 3 levels plus 1? Level 1 is essentially, there's a level 0, which is nothing at all. But level 1 is essentially very generic best practice. So your build system is automated and is scripted, and you generate provenance, meaning you generate things. You generate kind of how you build it. Level 2 is source integrity and authenticated provenance. Here, it's all the provenance that were generated. You want to sign them so that then you can actually verify that no one tampered with your attestation in between when you want to use your software and when it was generated. You should use version control for your source code, for probably your pipeline definition or your build system definition. And you use an hosted build service. Here, what hosted build service means is you don't build your artifacts on your laptop and push them to production. That doesn't satisfy level 2, for example. Level 3 is auditable build pipelines and ardent builds. Here, we want tamper-proof build system, meaning you cannot, during the build, tamper with anything you will generate. So for example, if you have a multiple steps or multiple task pipeline, you want to ensure that between different tasks, nothing can inject itself. And you want to restrict access to your signing material so that not everyone can see your keys, more or less. And non-falsifiable, I can't say this word, non-falsifiable provenance, which essentially is, you want to make sure that no one can falsify your provenance by, for example, running trusted steps or trusted script, etc. And the level 4, which was defined in the 0.1 spec, was about hermetic builds and 2% reviews and reproducible build. So we'll keep this at the end because it's still, I think in the spec it's there in the future. Like there's a place where we say level 4 will be worked on later on. All right, then let's talk a little bit about Tekton in one slide. I usually do a full presentation on it, so it's very hard for me to be very concise on this. First, who knows about Tekton? Okay, who used Tekton? Okay, that's a bit less than I hoped, but okay. So essentially, Tekton is a framework of some sort. Like it's a set of components that you can use to build a CI/CD system or more. It's kind of a workflow engine, so you could use it for machine learning and stuff. It was initially created by Google, Red Hat, everyone that was working on Knative, because it was spun out of the project. And as I said, there's a lot of components. We are only interested in a few of them, the core ones and a bit of results. So I'll just talk about these. So the first one is pipeline. So Tekton CD pipeline, this is the core. This is the main component that everyone gravitates around, or every other component gravitates around. And this is, the workflow engine. So you have steps, task, pipeline definition. Then you can execute them, and they're all standard Kubernetes objects that then will generate pods, run on your nodes, etc. Then there's chains, which is the most important one in the SLSA context, because this is the thing that's going to watch the execution of your task and pipeline and generate attestation, provenance, sign artifacts as well, and sign attestation. So essentially, this is the thing that is going to actually make sure that you can verify your build was done correctly. Pipeline as code is a new component that we adopted recently, which allows you to, it's a bit of opinion, it allows you to store your pipeline definition and your execution template inside your source code, like you do with GitLab or GitHub workflows. And results, which is the last part, we don't show it in the demo, but this is a key part as well, because it's a component that will store anything related to Tekton outside of the cluster, because at some point you will need to clean up your objects in Kubernetes, so you will delete some Tekton objects, and you still want to keep history about it. And the rest we can talk about it, but in another call. So let's go through the demo.
So what we just saw here with the architecture, we'll basically be going through all of it. And what we'll see is how chains actually creates the attestation, signs them, and stores them. And first, what we'll do is take a look at our kind cluster and see what all we have installed. Here, this one. Okay. So, so you can see over here that we have Tekton pipelines controller installed, right? And we also have chains installed over here. So we'll go through basically all of that right now and go through all of the setting that we need to do to run chains and make sure that whatever task runs, pipeline runs you run, the artifacts are signed at the end. So here you can see that this is our kind cluster. This is the controller for Tekton that we have. These are the 3 controllers that we are running. One of them is a webhook. And we have the chains controller, which will intercept at the end, pick up the results, and then sign them, attest them, and then sign them. Then this is the configuration that we have for chains itself. You can see that we are using the simple signing spec that was introduced by Red Hat. And then over here, you can see we have SLSA format for the pipeline run. And we have the same for task runs. And our storage that we're using is OCI. By default, it's not OCI. It's stored in Tekton itself.
What this means here is that the attestation and the sign attestation, etc., they all will be stored in OCI artifacts as well, alongside your, usually alongside the artifacts or the OCI image you pushed.
So like the image will be pushed and the attestation will be pushed alongside it. Yeah. You can see that, you can see some full queue stuff here. I'm not sure if that's how it's pronounced, but it's disabled. We are not using it right now. And the repository that we're using here is the TTLSH. So hope to the demo gods, like the internet is working fine, so we can like push everything. So we are also using a transparency log with record to make sure that we have all of this provenance information stored like outside somewhere, which is like accessible and non-tamperable. So this is basically the source code we'll be running, we'll be building. Then this is the task that we have. And over here, you can see that we are emitting these results, right? Image URL, digest, and attestation URL. If you go down over here and see that you can see that the results are being pushed. And this is, once these are pushed, after chains will check if these results are present based on the suffix, and then it'll pick it up and then sign it and then push it. So, yeah, one sec. Yeah. So now we are actually going to like create all of these resources and create our task run. So here we have the task run. We've created it, and we are creating the task run here. And these are the logs for it. If you can see on the right, you see the task runs run. You can see the pod that is being created.
Right, so here what we are doing is we're building an artifact. Here it's an OCI image. And once this is done, nothing will really show, but like chains as we speak is going to generate the attestation, and we'll see it now.
So now we'll take the task run and actually see what happened in the task run and see if like chains was able to intervene at the end and sign all the artifacts that needed to be signed. In this case, we are only signing OCI artifacts. So you can see that this is our task run, and you can see that there's this annotation over here that was put, and this was put by the chains controller as it was done signing everything. Okay. Then this was a public key that was used to verify this, and this is the task run succeeded. Yeah. Now we can go ahead and deploy this application, considering that it's signed. And now while we are deploying, we're actually going to check if we are using correct artifacts that we need to, and the artifacts that we are using are coming from the right place, and we are going to check the provenance and everything. So this part of the script basically does that. It runs the scan and prepares, does everything it needs to do before deploying. So once this step is complete, it will deploy the application, which is your simple Go server, which is like a hello world Go server.
So here we can see on the left, the source scan pod, which was one of the tasks, is completed. This means it succeeded, which means validated that the attestation was generated, that it was signed by the correct set of keys, etc. And now it's doing the last part, yes. Okay. It's a bit longer than we hoped for, but yeah.
Yeah, so it's going to now deploy the application because it's verified it. So this is the final phase. It's deploying it from this task, and you can see that the pod is being scheduled over here.
So one thing is, as I said in levels, level 2 means you don't run, you don't build your artifacts on your laptop. Here we do this for the demo, but like the assumption is that your Kubernetes cluster is not running on your laptop.
Yeah, it has to be a remote build service, so it has to be running somewhere somewhere in the cloud or something, but definitely not on your laptop. Okay, so here. Okay, so here you can see how the app was deployed. And you can also see that all of the task runs that ran and the pipeline runs that ran were intercepted at the end by Chains, and it was signed. So we know for a fact that they have gone through the Chains controller once. So Chains was able to pick these up once they were done and check if there were artifacts that needed to be signed, artifacts that needed attestation signed and then sent. So it has done everything over here. And these are logs.
Final demo. So for this one, we won't have time to go through all the logs, but essentially what we are doing here is we are redoing a bit the same thing, but we are using a work in progress alpha feature in Tekton, which is enforcing to run only tasks and pipeline that are approved, meaning that someone you know or someone like that are signed. Here it means like we are signing the task, we're also signing the pipeline lower, and then the Tekton controller is configured so that if with a set of keys, if you try to execute something that's not signed by those or by someone from those, it's going to fail to execute. This is alpha, so right now this is not enabled by default. There's a bunch of limitations still, but yeah.
So yeah, this is basically just signing a task, and then once it gets the signature, we are going to annotate it with the signature. And we do the same for the pipeline. As Vincent said, we don't have much time to go through all this. But you can see that the trusted pipeline was able to run over here, and we verified it as well. And this was verified by a verification policy that we have created. So this is what the verification policy looks like. This is the trusted task policy that we had created. And here you can see that we have the signature on the task that we verify against, right? So we know for a fact that we are using a trusted part of a pipeline. And this is the same one in the pipeline. Then, again, the signature. And okay. Now we know for a fact that the pipeline has succeeded. Yeah, this was basically like reaching up to like level 2.5-ish. Of SLSA, but yeah, through this demo, we were able to see that we crossed level 1, which is basically just creating provenance and having like an automated build process. So this is something you would run through like a hosted service and something that would be triggered on a commit or something like that. But first SLSA level is basically just provenance generation and availability. Now that this can be tampered with, we need to make sure that it's resistant from all that. That's what SLSA 2 is for. We harden that part, and we keep the build service out of people's hands. So like it'll be hosted somewhere, and we use like a version control for source code and the pipelines. So pipelines as code is being introduced to Tekton, and it's something that has been tested, and we are going to add this to upstream soon. Then we saw a little bit of what SLSA level 3 is. So SLSA 3 basically says that the build environment needs to be tamper-proof. Now, even if you're doing it with containers, it's possible that someone can tamper with them unless you have good security policies within the cluster itself. Like OpenShift has these by default, so something like that. And there is restricted access to the signing material that we need. And this is not in our hands, but it's upon anyone who builds the system itself, who'll have to be mindful of this. Then, as you saw, we had a verification policy in there, and we had SPIFFE in the works, and you saw that the task and the pipeline were verified before they ran. Then,
Yeah, so this one is, you can do it either using SPIFFE, so meaning it prevents you from running something that wasn't signed. You could also do something else where you run everything, and then at the end of your pipeline, or afterwards, you validate that you failed the pipeline if something wasn't signed. This is because the first one is alpha and not really yet completely battle tested. Usually people do the after one. And the trusted artifact one is also related to tamper-proofed build environment, because this is features that we're working on right now, where between each task, we have this proposal about making sure we have trusted artifact. We sign any artifact that's going to be output from a task and reused in another one, that we can verify that no one tampered with between two tasks. So if we were to reach level 3 as it was defined in 0.1, we would need hermetic build, fully isolated build dependency, and two-person review. So two-person review is outside of the scope because it's an organizational best practice. It's not related to Tekton at all. For hermetic build, there's an experimental feature which I cannot pronounce, which is a bit limited right now, or you can do it in your task. You can actually write your task to use unshare or anything. Well, the unshare or probably some other tool, but unshare is the one we use at least, to remove network access to your to one of the steps, the step that will build the OCI artifact, for example. And fully isolated build dependency, this is similar. This is doable by task author. So you can actually write reusable step, which is called step action in Tekton, which would fetch your dependency before the build process, so that then the step that does the build process is running hermetically. And one of the projects Red Hat created is called Hermeto. All of what we showed is Tekton only. And as you probably saw, it kind of requires a lot of plumbing. So maybe you like doing this because you can actually define your own build system the way you really want it. But you can also, if you don't want to do this, you can also use tools or services that are doing this for you. I listed 2 examples, and there's probably more. But there's the Conflux project from Red Hat, which is essentially doing whatever we did, but it's done by you. The only difference is it's doing hermetically sealed builds through the unshare, and it's enforcing things with a project called Conforma. So it's going to validate everything after the fact, but yeah. And the other one was Fresca, which I discovered recently, which seems to be a prototype implementation. I didn't see too much activity on it, but yeah, I discovered it. And yeah, that's pretty much it. If you have any question, please raise your hand. I think we have very little time for question, but yeah. One question or no question? All right, no question. Thank you very much. Thank you.